Good day, viewers. You are welcome to my YouTube channel, Maths with Adevic. I am Victor Adewale Adeleke. If you are yet to subscribe to my YouTube channel, do well to subscribe, like, and share. And what is our focus? Our focus is to teach you mathematics from the onset even up to tertiary institution. Okay, now we have geometry laws here and we want to prove it. Very simple. And you remember what I told you? I want to just continue this class like that on just geometry laws, proving geometry laws and all that. Now I promised in one of my videos that I'll be teaching or giving a proof of how Pythagoras brought out his very popular theorem, because he has several other theorems, but his very popular theorem is this one we called the Pythagoras theorem, which is a square plus b square equals c square. Okay, now let's see how did he come by that very beautiful formula. Now, one thing you must understand is let's take for instance that we have a right angle triangle like this of side A and B, two sides. Let's just focus on the A and B, and it has side ABC. Let's say side ABC. Now, what we need to note is that this is what angle 90, and if you arrange it in 4 places, you are going to get a rectangle. You're going to get a rectangle. But in this case, it is very, very unique. In Pythagoras' case, it is very, very unique that whenever you have the numbers arranged in the Pythagorean triple, because not all numbers can work in the Pythagoras triangle. So whenever you have those numbers fixed and you arrange them in 4 corners to themselves, they are always going to make a square, a perfect square. So it was from that perspective that we brought out this. You can see this, or just this one here was not duplicated or arranged in compacted in 4 ways to themselves. So that's what we had this one here like this in 4 ways. Now you can see that this completely formed a square, a perfect square, and this one also, which is inside, is also another perfect square. Now what do we do? It is very, very simple to understand. Now let's solve. Now what you must understand is that to get the area, first of all, how can we get the area of this square? Now we know that the area of a square is L times L, because the dimensions have the same length. So L multiply L, that's what we also have in here, the dimension of the same. If you want to get the total distance from here to here, is going to be A plus B. And if you want to get the area, it's going to be all squared. Now, what are we trying to do now? We just want to get the area of everything here. The area of everything here, that's what we're trying to get. We want to get the area of this square. Well, that's what we want to solve for now. So how can we do that? Now we know that let's get the full area, the whole area of this triangle, of this square. So we can establish a fact that the area of the square of square, particularly for this, not of any square, please mind you, of this square. So you can label it A, B, something, or PQRO. So, or PQROS, something like that. But the area of square, this particular square in context, must be equals to what? The area of the 4 triangles. Area of 4 triangles plus what? Plus the area of the square, of this small square inside. Area of square. So we can call, let's just say square M. Let's just call this one square M. Yeah, get what I'm saying now. So this bigger square, the area of this bigger square must be equal to the area of the 4 triangles, 1, 2, 3, 4, then plus the area of this small square inside. When you sum them up together, you are going to get the area of this whole square. So, and this area of this whole square is what? A plus B times A plus B, because like I said, the area of a square, length times length, because they are of the same dimension. So we have A plus B all squared equals to what? The area of the 4 triangle. What's the area of only this one triangle? The area of this triangle we can see is half AB. So what do? We multiply with 4, because not just one, but they are in 4 places, compacted it with each other. So we have plus area of square. What's the area of the square now? Still C square. So when we expand this, if you expand this one, you have A square plus 2AB, then plus B square, equals these 2 removes or divides the 4, and we have 2ab then plus c square. You can see we have 2ab here, we have 2ab here. What happens? They eliminate themselves perfectly, and we have a square plus b square equals to what? To c square. This is the Pythagoras theorem proved. So this is another very beautiful series to prove the Pythagoras theorem. Very simple and short. There are other ways, there are other mathematical ways to prove the Pythagoras theorem. If this one was not explained better enough, you can also comment in the comment section. I will drop a video also if you want. A much more difficult one though, but still just understanding the rule of mathematics, follow up, and you'll still come out with the answer. If you are yet to subscribe to my YouTube channel, do well to subscribe, like, and share. It is very important so that whenever I post materials like this, you will always get notified. Stay tuned for more videos.